Hello, and thank you for joining us for this webinar from OperatorCon. These are our online sessions. Unfortunately, KubeCon had to be postponed until August, but this is kind of how we make up for it and learn about operators in the meantime. So today we will be learning about infrastructure automation operators from Ken Owens, who is a Vice President of Cloud Native Engineering at Mastercard. Just before we get started, I want to highlight kind of some of our other webinars that are coming up after this. So next week, we'll be doing Introduction to Kudo, Kubernetes Operators the Easy Way, from two developers from D2IQ. Then we'll have Kube Carrier, multi-cluster service management from Nico, who's a software engineer at Ludsa. And if you have any questions in the course of the webinar, please feel free to drop them in the chat window, and we'll be answering them there. So with that, I'll hand it over to Ken. Thanks, Ken.
Yeah, thanks, Bill. Good morning and good afternoon and good evening to everyone watching. I want to just kind of do a quick introduction of myself. I can get this thing to work. There we go. Okay, so I am a technical executive with more years of experience than I want to admit to. I've kind of worked in financial services, IT services, communication services, and just in kind of in general technology stuff my whole career. I was a original founding member of CCF and on the TLC. I was one of the initial TLC members for the Tech Oversight Committee. So I consider myself a technologist first. I do have an engineering degree, and I'm work on routers and telecommunication systems. I did some ASIC development with embedded systems designs and ASIC development. Been in financial services industry. I've done development my whole career, and I do a lot of innovation always. As engineers, you're supposed to innovate all the time, right? I guess most importantly, I'm a husband, a father. I love to be involved in the community and do things in the community I live in. I love sports, both professional and my kids' sports, and then I like to be in the outdoors. You can reach me on GitHub and on Twitter at KenOwens12. So I thought, when you think about, infrastructure automation operators, the thing that came to mind for me was sort of understanding how you think about operators in infrastructure and in a large enterprise of any kind. And it made me think about one of my first career learning events I had was back when I first started working. I was in an advanced research and development group in Texas, working for a large telco that had global fiber optic networks. And one of our big customers was in the gas and oil industry, and they was sending images, very large images from the Gulf of Mexico to their headquarters in Chicago. And every Thursday evening, at different times in the evening, they would lose their network for 15, 20 minutes, just randomly. And no one knew what was going on. And I was being in the R&D group. We were like tier 4, the last line of defense or support. And after about a month and a half of no one being able to troubleshoot and figure out the problem, it reached our desk, and I was on call that day, that evening. And I got on the phone and I asked them, a very simple question. I asked them, there's this device that it's called a DSU that sits between the LAN and the WAN in the Chicago headquarters. And I wanted to understand, because on the network side, we knew we were getting the packets to them, but we were getting no response from them. So I asked them to look at this piece of equipment and let me know what lights they saw when I was doing some testing. And as I was doing the testing, they said there's no lights at all on. And so I told them to plug it into the back, into the wall and make sure that it's, it has power. And that was really the problem. They ended up putting some cameras up and noticed that the cleaning crew was coming in on Thursdays and unplugging this device, vacuuming. They still had carpet back then, if you can believe that, in the data center. So they would vacuum in the walkway behind the rack that this was sitting in, and they were unplugging it to plug in the vacuum cleaner. And that night I just got lucky that they left it unplugged. They hadn't left it unplugged until then, and so I was able to determine that the problem was that. So the key is like understanding what your problem is that you're trying to solve, right? So today my goal with this webinar is to kind of talk about what the problem is we're trying to solve. Talk about the solution that we sort of think we have for this. Then where that solution falls short, talk about some of the other things that we're trying to do in the enterprise space to accomplish the overall solution. And to give a couple of examples of what things that make sense to do in this space. And so as you think about the problem, we're not at KubeCon, but if we were, we'd be talking about the cloud native foundations, cloud native definition. And I kind of pulled out a few key words in here, right? But the main problem is that to build and run scalable applications in a very dynamic environment that we all work in, it's not an easy problem to solve, right? It's a very complex environment that we have today. Some of the techniques that are needed to do this, basically require a lot of changes that happen frequently. There is some predictability, but there's also a lot of unpredictability when you have services that are being consumed in different ways in different regions of the world. You can't just always expect predictability to always be there, right? And then as technology continues to evolve quickly, you're getting to a state of evolution that is happening faster than people can keep up with it in a lot of cases, right? And so how do we kind of think about moving towards this cloud native model in a way that doesn't break the operation of the services that you have, but also allows for the agility that we need to get to, right? So as you think about the operator model itself, right, I think organizations have always sort of been in this operator model, right? And so if you kind of look at the model today, you have a developer who says, hey, run my code. And then you have a group of people they have to talk to understand what they're trying to do, what's the business objectives, right? These are human operators that are sitting there to kind of understand the business side. And then you have your technical operators who want to understand what infrastructure and what platforms are going to be needed to support the code. They then kind of talk with different operators within each of their teams. They then kind of look at, talking with other operators in terms of how they're going to actually determine the importance and the financial aspects of the problem. Then you have, on the technology side, you have different individuals that are operating those environments who then work with different individuals within their spaces to then kind of look at how they're going to accomplish the different changes and the different aspects that are needed to support the application running. And so this model, while it's not, what you guys want to talk about today, I'm sure, but this is sort of the model that a lot of large enterprises have put in place for many years. And so we've been looking at this operator kind of model, but it's been a human operator, not a software operator. And when you think about, what the problem is, right, to really replace all of that human operator with software, you have to understand all the different things that you need to automate, right? And this is not a complete list, or not meant to be a complete list, but this is a list of a lot of the different things that need to happen within an enterprise in order to, fully automate what humans are doing today. And the current process is really not, that disconnected from where we want to get to in the different processes, right? So you have a development process today, you have infrastructure processes, you have the platform processes, you have your business processes, and then when you want to deploy your code, you have deployment processes. And then the one thing that I always try to think about is that change process. How do you manage change through this entire process? And so, as we look at the model we're trying to get to, we want to get to the model of services being what the code talks to, not humans. And so you kind of think about, your platform service, which then manages your deployment service and integration service. And you think about a business service, it's going to manage the prioritization and the finance processes. But in order to get to that point, there are challenges that I think we have to accept from the beginning that we're going to run into, right? And so a lot of that is that today that most people have automated processes with scripts, and they've automated the existing process. They haven't really looked at the process that they want to get to, and looked at how would they develop or define that sort of a model. And so today it's very much a, you know, knowledge base of scripts that get called in an automated way. You have a lot of state in storage right now. There's not a lot of development going on in a lot of enterprises that are looking at how to kind of minimize the state that's being maintained, and how to maintain that state better as metadata objects. There's a lot of external APIs that are just not available today. So a lot of existing enterprise systems don't have APIs, or they don't have APIs that are exposed to other teams to consume and to write to, and there's not a standard for a lot of them. And so, you know, how do you sort of live in this hybrid model of some integrations are going to have an API that you can use, and some integrations are not. So how do you manage those APIs that you don't have direct access to? The other piece of this is that what we're delivering is, in the end, a service, right? And that service has to have ability to get operated and maintained over time and supported. And so day two operations are definitely a challenge as you look at an operator model. And then decommissioning is also an issue, in that most systems are designed for create, but the modify or the delete options are not as easily automated as they could be. So just before I dig into the details, right, I want to kind of make sure that I summarize the problem. So, you know, you have to really understand what your current, and I put in quotes, operator model is, the human operator model that you have today. You need to then develop what you want that end state to look like. Don't just automate your existing broken or ill-defined, you know, processes because they've always worked that way. You know, think about the process first and foremost, right? And how do you make those processes more efficient? How do you make those processes more declarative? You'll hear me talk more about that in a few minutes. But you definitely want to get to a more declarative model. And so think about the process and how you're going to make the process more into this operator model. Then, you know, think about the people and the employees that you work with, and how do you help them adopt this new model and help them make the transition towards this operator model and away from the human interaction model that they're used to. And then at the end, you can then think about technology, right? There's lots of technologies out there, lots of ways to do this. Every company will probably pick a different way to implement it, but, you know, if you have the right process that you're shooting for, and you help your employees transition to this model, the technology is the easy part. So with that, Bill, I think I was going to pause for questions. I see we have one question in the chat. Oh, that wasn't a question. That was something from Bella. Sorry. Are there any questions at this point? Oh, okay, I don't see any, so I'll keep going. So at the next part of the presentation, I'll talk about what the solution consists of, sort of. And so as we think about the solution, it's taking a second to transition. Sorry. There we go. As probably most of you are familiar with, you want to start with the definition of done, right? And so declarative patterns are not new, but they are not, you know, very well defined in the enterprise space yet. And it depends on the enterprise, obviously, but a lot of enterprises are not that well defined yet. And so you want to basically, you know, move to this GitOps model from the human declarative model that we have today, and codify most of those patterns that today humans are doing. You want to think about the API first. And so, you know, one of the things that I've been very big at is looking at not reinventing the mousetrap. So there's a couple of different, you know, standards in the industry. Open API is one of the more common ones for API schemas. And so I was just thinking about, you know, leveraging what's already been defined and is state of the art there versus trying to create your own sort of API definitions and patterns. Think about your day two operations and look at the solutions that are out there today that detect drift and provide monitoring as part of the solution and do logging and support the entire life cycle of the deployment pattern. And so there's a lot of different mechanisms in place today that can do that. Again, don't need to reinvent that. You can basically leverage what's out there. And then you can basically look at as you look at your higher level systems, you want to think about what type of a stack or a set of services you can bundle together into a catalog item or into a console item that allows deployments to be done a lot more seamlessly and a lot less manual in nature, and a lot less moving parts and different components that need to be configured. And then for most enterprises, right, security and availability are very important. And so you want to make sure you're building a solution that is highly available, that has security as one of the first principles of the design, and can be distributed globally. The piece that a lot of enterprises think about first is the user experience, and I think that's really important when we look at an operator model. And so the main goal for us has been to kind of look at a spec that allows us to define that desired state that we want to get to. We want to leverage, sort of the built-in capabilities that our teams have defined around the platform for monitoring of the infrastructure and of monitoring the availability and some of the code things that we built into our code to look at the health of the application and kind of pull all that into one common view of the platform. We want to look at software that is able to kind of query for change and for ticketing. A lot of enterprises have change windows, and change windows may seem kind of crazy to a lot of people, but they do exist for good reasons, and especially in a large business that is relying on stability, you can't just make changes anytime you want to make a change. And so it's really important to kind of look at understanding when you can make changes and not having a human tell you to make a change, but have a software solution that can be monitoring for a window to open and know that they can make the changes inside that window and just automatically kick off the changes when it's a good time to kick it off and when it's allowed to be kicked off. The last thing then is sort of the control plane. As I look at this control model, I think a lot of my telco background and sort of the understanding of the entire system and understanding why you have a control plane and what that control plane is doing is really making sure that the data plane or the infrastructure is running the way it should be running. It's monitoring the health and the status of the infrastructure and is detecting any changes that could cause an issue or could be determined as a fault condition or could be becoming a fault condition. And so as I think about, getting into implementation a little bit, we sort of standardized on making sure that we start with the API and that we have, very strong CRDs for each of our set of services and stacks that we want to create. We've definitely gone down the controller path and are looking at, our initial platform that we developed was developed in a controller model, but there was no such thing as a controller at the time. And so, but as we've been moving down this path, the code that we wrote for our existing system and platform completely fits this controller model. It's been very easy to move to a controller model for us. And then the last piece is really, putting infrastructure into a GitOps model. We've talked about GitOps, a couple of times already, but that's really key in any sort of an operator model is to have that GitOps control model in place. And so as we kind of look at the specifics around some of the things that we're doing, right, from an API definition standpoint, this is an example of an infrastructure definition for a database. And so we created a name for that database item. It's version control, and it's tells you the type of database it is. And then when a client does a request for that, they're able to request a specific version, and either the region is defined declaratively based on the the type and the account it's provided to us. But we are looking at that availability type and defining different regional deployments that we can deploy that into. The specification file is important because we, like I mentioned before, you can think about individual components, but then that's kind of get a little bit complicated, right? And so you may need to have component configurations. And so, you know, on the left, I give an example of a Tomcat server component, and on the right, I'm talking more of a stack configuration. That's in this case a load balancer that you know, provides a little bit more information around the type of you know, service that this application could consume. And so the, you know, the key for us in this model is that we want to kind of look at having an infrastructure automation platform that sits, you know, between the APIs that we're exposing to our users and the back-end provisioning systems that are, you know, taking those patterns and deploying them. And then our goal is to sort of use this controller to kind of make sure that the desired state that's being asked for on the left is being met and the implementation being done on the right. The you know, some of the you know, solutions on the right are things that we do use today, but they're meant to be just, you know, more of an example, right? You don't have to have these specific tools, but these are the tools that we're using today to accomplish the controller model. There's a couple of different components that we've, you know, been looking at using the controller model. The first one is kind of a watcher service that is kind of providing you know, different changes or drift in a specification file that's been submitted. It compares that to the actual state, and then it will make, you know, changes or provision request based on any changes it detects. And so that does solve, you know, that is a solution that we've implemented. It does solve a lot of problems, but it doesn't solve everything. And so when I think about, you know, how we solve everything, right, the first thing I think about is trying to understand what are the boundaries of what you know, an operator model would solve, right? And so in our case, we looked at kind of the software development lifecycle, has some very important aspects of what we're trying to solve for. Those component definitions I mentioned before, right? What are the different aspects we're trying to write an operator model around, and, you know, are those component definitions or are they stacks, and how do we kind of manage that going forward? We're kind of looking at the different platform services that we want to provision these applications into, and how we do that deployment model. Understand the dependent services that these different teams have inherently when they write their development platforms, right? So there's authorization and certificate services, and, you know, other secure services that are underneath the covers that the team rely on, necessarily exposed to the world to see. And so they have to kind of know how to get to those services. And then there are business services. So that's kind of the what. And then there's sort of the why that we're trying to do this, right? So the main reason is to look at the customer value, right? We're trying to deliver value to our customer. We're trying to give them the ability to, you know, deliver their code as quickly as they can, as securely as they can, and as available as they can. So the quality is important to them, and, you know, financially, there are things that, you know, gates or whatever you want to call them, that need to be met in order to move forward a certain solution. And so one of the things that we, you know, talked about a little bit is this GitOps model, which to us is really important to kind of look at the, you know, to pull repos, calculate the diffs, you know, apply any manifests that come in, and then enforce the security controls that we have to enforce in any regulated industry, right? And the key there is that we want to be able to take it from any source and be able to provide it to any destination. And Kubernetes is something that we've standardized on as a kind of abstraction layer of any destination. And that doesn't mean that the application developers are necessarily doing anything with Kubernetes, but from a controller and operator model, we're leveraging Kubernetes as sort of that abstraction layer to go to any destination. This is you know, a good example of kind of what we're trying to do So we've been able to kind of look at a solution that applies to manifest automatically. It enforces within that deployment only those services are able to communicate with themselves and with the shared services that it's connecting to. So there's no ability to bypass the security controls that are kind of built in under the covers and enforced through the security operators. So there's no way to sort of define or manage those independently. Providing infrastructure logging and monitoring as a first-class citizen of the deployment is a key objective we met, and then sort of being able to give them a way to visualize the relationships that they have within not just their code but also the different components that they're talking to, and then providing that status and health of those components. And so then with that, I want to kind of give an example of what we've actually developed and show you kind of a demo. So we have this interface that we call Cruise. We've open sourced this in the Cloud Native Compute Foundation in user community as something that's sort of for a developer experience, if you will. And so we have some information on here that is sort of basic metadata about the application that a developer would provide. There's some security components that again are very lightweight. We have a lot of declarative operators built in behind the scenes, so that we can take a very simple question like what's your data classification, and that can equate to lots of different configurations in the back end without the developer having to understand what security controls are being built in. They're just built in by definition. And then for their application piece, I think they can define their components that their application consists of. They can define the type of workload. We give them the option to select multiple data centers. And then we have different traits that we consider are dependent services that allow the application team to say, yes, I need certificates, I need message signing, I need to be able to provision a user, I need to be able to send SMS to mobile users, types of dependent underlying services that are available for them to use and consume. And that information is all they have to select. They have to click a radio button. There's no additional details needed because it's an operator is sitting underneath the covers that will maintain the declarative state to configure those services to work with the application on the developer's behalf. And so, this one example here, shows what that sample of Cruise kicks out. We are using, as you can see from that API version line at the top, we are using something for Terraform. As you've probably seen, Terraform released an operator, probably a team to not, reinvent the mousetrap like I mentioned earlier. And so our goal is to look at, what the key to kind of this operator model in my mind is to kind of understand the whole problem, not just a sub piece or a process, but kind of think about the end state you're trying to accomplish. Know that the entire problem might take time to get to. So think of a way to iterate to that end state. Looking specifically at the operators. Understand what operators exist today in the industry, which ones don't exist, and if you need to create some type of a custom resource definition, then that fits the model today. But think about over time how that's going, the life cycle of that model and that operator, and how that's going to evolve. And then, like I mentioned earlier, operators do solve some things, but they don't solve everything. So keep iterating towards that solution. And with that, I want to thank you for your time today and open it up for questions.
Thanks, Ken. That was really insightful. Do we have any questions that people have? If you want to just type them in the chat, that'd be great. Yes, Ken, I have one question for you. Like, what's kind of your roadmap with Cruise?
So right now with Cruise, we are looking at partnering with the SIG app delivery group. As you probably saw, Argo, which we also use internally, has been submitted to the CNCF. And so one of the things we've been doing is working with the Argo team a lot on Cruise. And so our next step is to kind of look at how do we, take Cruise, add some of this operator specific things we've done internally to the community, get adoption within the end user community, and then look at following the same path that Argo did with the SIG app delivery.
Cool, that sounds super exciting.
We are it is on GitHub, and so we're very happy for contributors. Or if you're interested in looking at it more, please look at it on GitHub. It is open sourced, and so we has started with more of a kind of a cloud native model than what I showed you here. This was more of an internal kind of experience with operators we've developed, but we do have an open source version of it that we will continue to update with this own model. That's probably our next step, is to kind of get the own model updated into that open source contribution, but then definitely partnering with other enterprises, other end users in the CNCF to kind of take this forward, because we do know there's a big gap in the complexity that is required to sort of abstract all of the different components that are needed in the infrastructure. And so this operator model, we think, is a really strong technology and business model that we can put in place.
Cool. And there's a question: can you post the URL, or do you know where can people find more information?
Yeah, I can definitely post the URL.
And another question while working on that: what do you think about cross-functional teams, and where do you see them now and in the future?
I see cross-functional teams sort of looking at, it's kind of an older term, so hopefully you won't, get too upset by me saying this term, but I kind of look at cross-functional teams as being more of an operator model in itself, with and I use the term SLAs. That's the term I was kind of trying to avoid. But and when I say SLA, it's not traditional SLAs that are multiple days or weeks of SLAs, right? But I think cross-functional teams have to kind of define what their service objectives are, and how they're going to accomplish those service objectives in a declarative manner that isn't going to kind of manage and maintain drift. We have our experience in this area is really not unique, but I think it's insightful for a lot of people, because it's as we've looked at the cross-functional teams we're working with today, there's a certain bit of knowledge that they build into their job that they don't really realize that they build into their job, right? And they think they're doing things in the GitOps way, and they'll make a change, and the platform will pick up that change and test it, and it fails, and they don't understand why it failed, but they just know that it failed, and so they'll reach out to ask for someone else to help them with why it failed, and the failure message would pretty much always tell them what failed and why it failed. And if they just looked at the message, they would say, oh, okay, so I need to go change this part of what I just updated because I didn't update the version, or I didn't change this one piece. And in a lot of cases, it's very open, easy problem to solve, but they're not wired to think about looking at those messages and trying to figure out what went right. And so I think the insight there would be to kind of think about, how do you create a service, how do you maintain that service, and then how do you sort of put some SLAs or SLOs around that service to ensure that you're delivering the value that you are proposing to deliver with the service. I think the other part of your question is, are those cross-functional teams going to go away or converge? And I think there's going to be a combination of both. Right? I think you're going to have some teams that are, going to, move into, other groups and sort of look at more of an organizational type of solution to the problem. But I think other teams are going to remain cross-functional and will always have the dependency on other teams that needs to be kind of defined in code and supported in code.
Thanks. I think that was a great answer. I don't see. Yeah, thank you from Gabriel.
I did post the URL. I don't know if you guys got it in the public chat.
Yeah, it should be in the public chat.
If it didn't work, let me know. We can email it out later if you want to, Bill.
Yep, we can add that afterward. Are there any more questions from the audience right now? Okay, great. With that, I want to say, first of all, thank you, Ken, for the presentation. I think it was a great insight into see what kind of like an exciting company like Mastercard is doing at the operational level, and where kind of operators are going in the Kubernetes space. So once again, thank you for attending. The recording will be sent to everyone after this presentation, so you'll be getting a follow-up email. If you want to attend further webinars, next week we have Introduction to Kudo, Kubernetes the Operators the Easy Way, with 2 engineers from D2IQ. The week after that, we have Kube Carrier, multi-cluster service management with Nico from Ludza. Yeah, and please feel free to reach out if you have any questions. With that, I'm going to end the webinar. Thanks for coming.
Yeah, thanks everyone, and you can reach me at KenOS12 if you have any direct questions for me as well.
Yeah, so please.
Thanks, Bill, and thanks for the OperatorCon going with KubeCon being suspended. I think this is great.
Thanks, Ken. It's wonderful to be part of the community.